So we can look at recursion, and this little video is going to show what not to do and what recursion is. So I'm going to show you recursion in its simplest form. Okay, so I'm going to write a function here, or a method here. I'm going to call it do something. Okay, and all this method is going to do is to call itself. Okay, and then I'm going to call that from the main method. Okay. So if we think about what's going to happen, we're going to get stuck in some kind of infinite loop, because we're going to go in to do something, it's going to call do something, and we're just going to keep going around. So let's run that and see what happens. Okay, so you can see here we've got an error, and if we scroll up through the stack trace for a long way, we get right to the top. It's going to say exception in thread main java.lang.stack overflow error. Okay, you've probably heard the term Stack Overflow if you've searched for solution to a problem on the internet, because it's the name of a well-known programmer's sort of question and answer site. But essentially, we have run out of memory on the stack, and therefore the program can no longer continue, because we've just essentially kept calling the same method over and over again. Okay, so we don't want to do that. We want to make sure that if we end up calling the method we're in, or even a method that calls the method we're in, if we end up with some kind of step that results in a circle, there becomes some point at which that we exit. Okay, and we can stop. Okay, so I'm going to write another method that's going to use recursion. It's only a very sort of trivial method for an example. You probably wouldn't use recursion in this particular way, but what we're going to do is print out the numbers from 1 to 100. Okay, and we're going to use that, use recursion to do that. Okay, so let's change this to count to 100 from, and we're going to give it a starting point. Okay, so int start. And what we want it to do is to print that out, and then if you think about it, if we start at 0, we can print 0, and then we can count to 100 from one more from that. So we just add 1 to that and call this method again. Okay, so let's say count to 100 from 0, and let's start at 1. And then we'll print out start, and then we'll call count to 100 from start plus 1. Okay, so if we run that, we're still going to have a problem. Let's run it and see what happens. Okay, so we've got the same problem. We've got a Stack Overflow error. Okay, we got to a relatively high number. So we had about, it's going to be hard to find exactly where this is. There we go. We had about well, 10,000, almost going on for 11,000 calls before we ran into a problem. Okay, so there is a limit, clearly a limit, well, at which point we reach a Stack Overflow exception. So what we need, okay, this is what we'd call like a reduction step, where we call the method itself, but we need a way of ensuring that our recursive step exits. A recursive method exits. So what we do there is we create something called a base case, and in this case we want to say, well, if start exceeds 100, then we simply return out of the method. Okay, so we exit the method. Or we could say, maybe for clarity, print it first, and then say if it's greater than or equal to. It should only ever actually get to 100. If not, we have our reductive step where we continue going. Okay, I'm not advocating this particular approach as a good use of recursion, but hopefully it will help us to understand the principle. Okay, so there we go. We're getting to 100 there. But what I'm going to do quickly is just put a breakpoint in here, and then I'm going to run this with a debugger and just show you something. Okay, so here is the debugger. In fact, let's put it inside the return statement and hit continue. Okay, and if we now look at the call stack, okay, we can see we've got 100 calls sitting here. And if I click on them, you can see the various different values of our start value. Okay, so you don't really want the call stack getting particularly or too large, because you run the risk of that Stack Overflow exception. Now we're nowhere near that because we got to 10,000 odd last time we did it, but we just want to be aware that, you know, actually this method has been called by this method, which has been called by this method, and you can see that call stack. And if we go all the way to the bottom, you'll see we've got main sat there. Okay, so main called count to 100, which called count to 100. And if I press up on the keyboard, you can see the start number going up. Okay, so just be aware that that's what's going on. Obviously, if I continue, we get our output and our application terminates. Okay, so if you're going to call a method which eventually calls itself again, make sure there is a case, a state that can be reached where it no longer continues. So essentially here we are returning, which prevents this from happening when we reach a particular condition. In this case, the value gets to 100.